All right, so we finished Unit 1 and we're moving on to Unit 2. And there's a little review of the things that we covered in Unit 1 here at the beginning. I just want to point out that remember for our quantitative variables, when we're talking about describing a distribution or comparing a distribution, we really want to make sure that we hit all those aspects of SOX, the shape, the outliers, the center, and the spread, and that we're using comparative language if we are doing comparing over two groups. So we see in histogram, dot plot, and stem plot, what we were supposed to take away from the Barry Bonds activity was that in all three of these, we can actually see the shape of the distribution, right? The modes, symmetry. And in the box plot, we can kind of see symmetry, but it's really hard to see whether we're dealing with unimodal, bimodal, multimodal. So we're kind of limited, which as you saw in that FRQ that I forgot to have us grade our own, any mention of shape in that box plot comparison was just ignored because it's really hard to see. And then remember when we're talking about our center, we could be talking about mean, median, or mode. And if we're talking about spread, then we're talking about standard deviation or IQR, or even the range is completely fine, especially in those FRQ type situations. So just wanted to do a little quick recount of all that. And then if we wanted to chat about the outliers, we had two ways that we looked at outliers, right? Just as a recap for this O, right? Our outliers, we could do a z-scores, and we said any z-score more than 2 or less than -2 would be considered unusual by the AP standards. And we also had the fences in our box plot as another way to check for outliers. So we had those two methods. So now we're going to move into two variable data. So in theory, we kind of have already seen two variable data. When we talk about comparing a quantitative variable over two groups, well, we're essentially doing this. And it doesn't even need to be two groups. That one FRQ I brought up quickly on the board had like 3 groups. I think it had like 3 different types of, I don't know, it was like something about types of chemicals in dirt or something weird. It had like 3 or 4 types of chemicals for like 3 or 4 different sites. So it was like a bunch of variables all at once. But we're in these situations comparing a categorical to a quantitative. And now we're going to move on in part 2 and see ways that we can look for relationships between two categorical variables and two quantitative variables. So we're going to start with two categorical variables. And that's what I'm going to have our knowledge check on Tuesday. So we're talking about representing two categorical variables. The easiest way to do this is a contingency table. So we're going to sit there and we're going to do this little table as our first thing in class. So we're going to skip this, but I'm not even going to fill in the side until we actually can talk and say, what are you guys' favorite social media sites? But we'll see this. So basically a contingency table allows us to display two categorical variables. And we'll go ahead and look at this in the next example. So in the first example, we see we have two categorical variables, as I just said. We have the type of driver who owns a car, and then we have the type of car, right? So you can see here we have American, European, and Asian cars, and we have student and staff drivers. So we have two categorical variables, one, what type the driver is, and two, where the car is from. And then we can look at this if you needed help reading it. These 108 in that particular cell, these are student drivers with American cars, right? They fit both this and this description. If we go all the way to the end, here in this 212, we've added the 108 student drivers with American cars to the 104 staff drivers with American cars, and we have gotten the 212 total American cars. So this total column refers back to whatever that row was. And the same thing in the other direction. If I added up all the different student drivers and the cars they drove, I would get in the total row here, the total for that column of student drivers. And then we have at the very end, everybody in this particular table. So that's how we read these tables. And most of the time, the questions that are asked about these tables are finding percents for certain groups. So I would take a moment if I were you and just try to find each of these percents on your own. You don't even have to calculate the percent, just make your fraction. Pause, then come back and see if you got them right. So the first one, the only thing we're told is that the cars are European. Nothing about the type of driver. So we want to go past the student and staff columns, right? Because I don't want just the student or just the staff. I want all those European cars. So we got 48. And it does say we want of all cars. So this is out of our 362. All right. The next one says, what percent of American cars were owned by students? So let's start over. In this case, we want American cars, students, American and student. So our numerator is going to be 108, right? Where those two things intersect. Now, we have to be careful here. It says what percent of the American cars. We don't care about all cars. We only care about of the American cars. So this is our whole of what we're looking for. So this will be what we divide by, 212. All right, so of the American cars, the 212 American cars, what percent were owned by students? And then our last one, well, what percent of cars were Asian and owned by a, oops, I wanted blue. Were Asian and owned by a staff driver? Asian, staff. Well, again, we could start over. We need a staff driver. We need an Asian car. So the part that we're interested in has got to be this 46. And then hopefully you recognize that we're talking about of cars. So we actually want to divide by all 362, not by one of those other category totals, not by the 165 and not by the 102. Another way to spot this, by the way, is, oops, whoa, fascinating, is anytime we see the word and in these questions, in terms of the grammar here, it's telling us that our part, the thing that we care about, these two things are linked together and that's their own piece of the sentence. So anytime you see the word and you could even make yourself a little note, you're going to want to have to divide by the overall total as opposed to one of the what we call marginal totals. So I'm going to go ahead and get those percents for us. So I just threw those into my calculator, moved my decimal place 2, and I got my percents. I do want to point out that these all technically have different names if you wanted to recognize that these are 3 different types of probabilities. The first one that we found, this is called a marginal probability or percent. The reason here is that we only ever use the margins, right? We didn't even need the fact that we had a contingency table. So in this case, we have a category total over the overall total. The next one, this one is called a conditional probability or a conditional percent. The reason is that we've conditioned on, we don't need to talk about everybody, we just care about this one group. So in a conditional probability or percentage, we're going to be looking at, I guess we call this maybe an overlap, just to make things kind of, trying to think of a short way to do it, divided by a category total instead of the overall total. And then the last one, this blue one, with the and, we call this a joint percent, joint probability. And this is going to be a overlap divided by the overall total. So you can see the mechanics of all of these are different. I only tell you this because on the test, I usually give a contingency table problem, and I will most likely ask all 3 of these or 2 of them perhaps. And the most common mistakes especially are mixing up these 2 right here in terms of not paying close attention. But if you pay close attention to that and, or what did we say we were looking at in terms of a group, you should be fine. So the last piece here is that we can make a conditional contingency table, conditioning on the type of driver. So remember, the green one was conditional. So with a conditional table, we're going to say, okay, I realize these totals weren't the same, right? I realize we had more student drivers than staff drivers. So we might want to go ahead and sort of make these so we can compare them, almost like a z-score does, right? Like I want to compare apples and oranges. So what we do is whatever we're conditioning on, in this case, the type of driver, we're going to divide by that. So that's what we're going to divide by. So I'm going to recreate our table, and I'm going to show you what I mean by this. So we need our table back. Boop, boop, boop. Guess we need 3 categories, right? So we have our student, we have our staff. I hope those are the right order. And then we had American, European, and Asian. All right, so what I'm saying here is that in that first category of students versus American cars, we could make, oh, I'm going to not have enough space. This is going to be rough, but it's okay. We could make a table where we just divide everything by 362, right? The overall number. And that would just give us overall percents. That's a table. You'll see it sometimes, but it's not very useful in looking, again, to try to compare the students and the staff. So what we're going to do here is we're going to divide this by 197 because that's what we conditioned on. So that 108 divided by 197, we're looking about 55%. I'm rounding because I have no space, so 55%. All right, and then we do the same thing with the next group. So it looks like we have 33 European cars, 56 Asian cars, and all of these are out of the 197, right? Because these are all driven by students. So of the students, 55% are driving American cars. Oops. Let's see what percent are driving European cars. We've got 17% driving European cars. Obviously, that's a lot of rounding, but I can't fit anything more. And the last 28% are driving Asian cars. So if we add all of these up, right, we would get 100%. So all of the student drivers, what did they drive? And we could do the exact same thing with the staff drivers. I'll pause and then just show you the answers so you don't have to watch me do a lot of math. But the 104 now, 15, 46, I'm just writing down those totals. Every one of these is going to be divided by the 165 staff drivers. So we can kind of see how that would look. So eventually, again, we're going to get 100% of staff drivers. What were they driving? So we end up here. Now, one thing we can do with this is to try to figure out if there's any sort of relationship between the type of driver and what kind of car they're driving. Another way to see this, and this is something that AP really likes, is sometimes they'll give you this table, then they'll give you a display. So the displays for this sort of data would be like a stacked bar chart, a split bar chart, or our mosaic plot, right? So I'm going to go ahead and make this into a stacked bar chart. So we'd have our 2 bars. We'd have our students, and we'd have our staff. Ignore the fact that those get fat at the end, right? And then we'd probably have an axis here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Assume those both went to 10. Dread it. I'm going to have to redo them so that we can go to the 10. It's either that or I have to redo my axes. This seems easier. All right. So now a stacked bar chart. Each of these things will be 100 because in this stack bar chart we have conditioned, and that's usually how they will do it on the AP if they give this to you. And we know 55% of this for the students is American. And we'd make a little legend. 63% of the staff, that's a little bit higher, right, is American. European is 17%, so almost 2 bars for the students. And I'll make this one really dark. And it's only 9%, so just one little section for the staff. And then the rest is Asian. So I guess I should make that. This is a stacked bar chart. And one of the things they like to ask you is to compare these distributions. And now we can't use SOX because we're not talking about a quantitative variable, but we can talk about like, oh, it looks like a larger percentage of staff are driving American cars compared to the students, and the students are much more likely to be driving a European car than the staff, right? So it looks like there's a little bit of a relationship. Not a huge one, obviously. There's not a big difference in this chart, but definitely compared to, oh my God, my brain stopped working. Compared to like not seeing anything at all. So let me show you one more example of a chart that we can kind of look and compare and look for a relationship in. I just have to go find it really quick. All right, so I found this mosaic plot that another AP teacher made of the different AP exams and their scores. So you can see by just looking at the segmented bar chart, Calc BC has the largest proportion of 5s and the smallest proportion of 1s. And it looks like the hardest test based on this to get a 5 might be CS Principles, right? So we can see here it looks like Calc BC is the most likely to have a 5s, whereas CS Principles is 9. So we could actually say that there might be a relationship. On the right, you can see this as a mosaic plot. So you can see the largest group is the Calc AB. Most students take Calc AB, whereas BC and the CS classes are much smaller proportions. But yeah, this type of plot allows us to look and say, okay, it looks like Calc BC might have the best success rates. Now, we can't say that that's caused by Calc BC's test being easier or anything like that. In fact, Calc BC is sort of a self-selection. Usually only the strongest of students are taking Calc BC. So that's why we see that difference.